Welcome back to Math Workplace 30. We're going to start today with Chapter 1.1 and reading the Explore the Math on page 13. So go ahead and read that passage. Then you can complete the definitions of linear relation, slope, and direct linear relation right from the textbook. So next we're going to look to example 1 on page 15 about the water flow. Do you expect that this relationship is linear? Why or why not? So when considering something is linear, we want to look if it is a constant value that we're considering. So is the water flow constant? Yes, it is, which would make this linear. And it is linear because the water flow is constant. Now, if you look to number 2, how many data points are provided? Is there enough to draw a graph? So what data points do we have here? So yes, we do have 2 different points. The first point that you can look at is the 340 liters and the 990 seconds. Note that we want everything in seconds because we need to have a common form of measurement on one axis. So we're going to go with liters on the y-axis and seconds on the x-axis. Our other point is when the barrel is completely empty, which is at 0 liters and 0 time has elapsed. So we have 2 data points provided, and yes, we have enough info to draw a graph. So part 3 is to graph the volume of water compared to the time in seconds. And you can go ahead and do that now. When you're finished, please check with my work and make sure they're the same. Note that you have 2 more definitions here to consider. Okay, then we want to look at number 4, which is we're going to find the slope of the line. Now slope, you can write this formula down, is if you have 2 points, we say y2 minus y1 over x2 minus x1, where we could say that this is our second point, where we have 990 as our x value and 340 as our y value. And our first point here could be the point 0, 0. So we have point 1 and point 2. So if we're going to plug that in here, our y2 value is 340 minus 0. Our x2 value is 990 minus 0. And if you type that into your calculator, what do you get for your slope? So your slope should be 0.343. Now, if you look to question 5 on the next slide, it asks, what are the units of the rise and what are the units of the run? So what are the units of the rise? Liters, good. And how about the units of the run? Seconds. So this slope, what would the units of the slope be? Good, it would be liters per second because our slope is our rise value, which is our liters, over our run value, which is our seconds. So liters per second is our new rate of change variable. So rate and slope are interchanged when we're talking about 2 different units. Now for number 6, so what is the flow rate? Good, it's 0.343 liters per second because it's the same slope, but then the rate we have to add in our proper variables. And how about number 7? If you look at the graph, how many liters of water were in the barrel after 5 minutes and after 9.5 minutes? So after 5 minutes, how many seconds is that? If there's 60 seconds, good, it would be 300 seconds. So we look over here at the 300 mark and go up and put a point about where that would be. So what would be a good estimate? Good, 110 maybe. So our point there would be 300 and 110. And how about at 9.5 minutes? How many seconds is that? So 9.5 times 60 will give us our number of seconds, which is 570. So we look over here and 570 would be somewhere in there. Go up until you hit the line. Get about 200 liters. So it would be 570 seconds and about 200 liters. Now, how accurate is this? When we are this is really just a guess. So this would not be the most accurate way, but throughout the rest of the chapter, we will find more accurate ways. So next up, we've got some mental math and estimation. You can go through parts A and B. Note that when you have something like 11.99, when you're estimating, it's best to always round that off. So your close estimation would be 12. All right, so then once you're finished, make sure you check your answers on the board. Note here, when I took 9 and divided it by my fraction, that was because I'd have 9 hours, and I want to figure out how many of those can be done in that time. So next, we have discussed the ideas. All of these graphs that we've looked at so far have had 3 things in common. What's the first thing they've had in common? They're not just graphs. What else do they have in common? They're at 0 and 0. Good. What else do we know? I heard you say they're linear. Okay. Somebody said that. So they're all linear. And what do you notice about their slopes? If you look at this slope, good. They're all positive slopes. Okay, which means they all go up like that. So they've all been direct, linear, which again means that they start at 0 and 0. They have positive slopes. So, yes. So our new definition is that we have positive linear relation. So that is when you have a linear relation that does not start at 0 and 0. So direct ones start at 0 and 0, partial ones do not. So let's try this next one. We're going to plot this graph showing the cost of the rental van compared to driving distance. Go ahead and try that on your own. Right, so once you have your graph drawn, again, it's easiest to start your graph by drawing a table of values like this, where you have your distance versus your cost, and then your final product should look as it is on the board. Now, is this a linear relation? Why or why not? Yes, it is a linear relation. It does make a straight line, which could be one of your reasons, but the main reason is that it's constant by how much it goes up for each kilometer driven. So yes, it is a linear relation because it increases by constant amounts. Now, does the graph pass through the origin? No, it does not. So what type of linear relation is this? Partial. Good. So that makes this a partial linear relation. Okay, then if we look at scenario 2, go ahead and graph this. She has $200 to spend on food. She spends $18 on average each day. So again, create a table of values first. That table of values will have your days and your money remaining. And go ahead. Okay, so once you have your graph completed, it should look like this. Now you'll notice that this graph is different because it has a negative slope, or it goes down from left to right. Now, this is also a partial relationship because it does not start at 0 and 0. If you'll notice, it starts up at 200 and 0. So how is this graph similar to the graphs in example 1 and scenario 1? So example 1, and if we look back to example 1, this is example 1. You'll notice that example 1 is linear, but it is a direct relationship. Whereas scenario 2 is also linear, but it is not direct relationship. So the only thing they have in common is that they're linear. Now, scenario 1, is also linear and it's a partial relationship, so is scenario 2. So what they have in common is they're both partial relationships. Now how are they different? So example 1 is different because it's a direct relationship and it also has a positive slope, whereas here scenario 2 has a negative slope. So scenario 1 is also different from scenario 2 because it has a positive slope as well. All right, so that's it for the lesson today. Your homework is from your textbook, page 22, numbers 1, 5, and 6. Please have that completed for tomorrow's lesson.